In this problem, we're asked to find all solutions of the equation cosine of ln of x is equal to 0. Therefore, we are looking for letting theta equal to the ln of x and trying to figure out solutions where the cosine of theta is equal to 0. Cosine of theta is equal to 0 at every odd multiple of pi over 2, 3 pi over 2, and so forth. This would give us theta is equal to pi over 2 plus n pi. We would need to take this and now substitute for theta being the ln of x. In order to solve for this, we can use the inverse function or the natural exponent. E to the ln of x is x. Therefore, our solutions are x to the pi over e to the pi over 2 plus n pi. In our next problem, we are asked just to find the solutions in the interval 0 to 2 pi for the cosine of 2x minus pi over 4. In order to solve this problem, we can figure out first the general solutions for the cosine of 2x minus pi over 4 equaling to 0, and then find those specific to 0 in the interval 0 to 2 pi. If we let theta be equal to 2x minus pi over 4, then our general solutions for the cosine of theta equaling to 0, again cosine of theta equal to 0 at every odd multiple of pi over 2, that would give us theta is equal to pi over 2 plus n pi. Solving for 2x minus pi over 4 is equal to pi over 2 plus n pi. Adding pi over 4 units to pi over 2 would give us 3 pi over 4 plus n pi. Dividing everything by 2, we get 3 pi over 8 plus n pi over 2 as our general solutions, but we are only interested in the case between 0 and 2 pi. Therefore, we're going to find the values for our solutions when n is equal to 0 through n is equal to 4. To make this easier, we could write this with a common denominator. Therefore, x is equal to 3 pi over 8 plus 4n pi over 8, recognizing that we'll add 4 pi units to our numerator each time. So when n is 0, we'll have 3 pi over 8. When n is 1, we have 3 pi over 8 plus 4 more pi over 8, which is 7 pi over 8. When n is 2, we're going to be adding 8 pi over 8 plus 3 pi over 8, which is 11 pi over 8. Again, noticing the adding by 4, therefore the next one has to be at 15 pi over 8. In this problem, we are asked to find the solutions in the interval 0 to 2 pi for tangent squared x, sine x is equal to sine x. The first thing we would want to do is bring everything over to one side so that we can factor it. Factoring out a sine of x would be left with tangent squared of x minus 1 is 0. Therefore, sine of x is equal to 0, or the tangent squared of x minus 1 is equal to 0. Solving for the first set, sine of x is equal to 0 in the interval between 0 and 2 pi at x equal to 0 and at x equal to pi. Now looking at tangent squared x minus 1 is equal to 0, we are looking for values where the tangent of x is either equal to a positive 1 or the tangent of x is equal to a negative 1. In this case, where tangent of x is equal to positive 1 is in quadrant 1 and 3, or pi over 4 and 5 pi over 4. Tangent of x is equal to negative 1 in quadrant 2, 3 pi over 4, and quadrant 4, 7 pi over 4, giving us our 6 solutions.